and students and enthusiasts. So we are taking a new topic today, that is microprocessor and microcontrollers and their the fundamentals of these two parts. Right? We'll do this with to understand the core of embedded system basically. So I will just go through the slide first, then we'll discuss some practical part. So what is microcontroller? Or rather, first we'll study about microprocessor. It is a general purpose processor unit, right, which executes some instruction which are provided to input, right? It is nothing but it's a binary data input and binary data. It provides results to us, right? Which is, we call it as a CPU processing unit. It has a processing unit, memory and bus that carries data, address and controls information used in personal computers. Where it is used in personal computers, laptop, tablet, smartphones, you will find microprocessors. Right. I will just go a little more into it and I will just tell you. We have already studied about integrated circuits. So it is, this microprocessor is also an integrated circuits, which is made up of thousands and billions of transistors. Okay, thousands and billions of transistors it is made up of. There is a silicon wafer. On the wafer, the transistors are arranged, or the circuit is made with the thousands and billions of transistors. The only difference, microprocessor, it takes help from outside, the surrounding components, to help them, right? Like the memory will be outside and other things will be outside. Now we'll talk about the microcontrollers. Compact integrated circuit design to perform specific task. It will be, you have to remember this point, that it does a specific task only. Okay, not like processor, it will do multiple tasks together at a time. But controller, that is microcontroller, it will do one specific task. It is also a chip. Okay, so this is, we'll go to the second slide. Now you can see the definition part here. A microprocessor is an integrated circuit that processes data and perform tasks that we have already discussed. What are the key features of microprocessor? It has a central processing unit, no built-in memory. Okay, the memory is outside, right? Or peripherals, general purpose processing. This general purpose processing we call it as, and the peripherals are outside. Let's see the other one. What is a microcontroller? Definition: a microcontroller, complete integrated circuit designed to perform a task, a specific task. That also we have discussed. What are the key features? Include CPU, memory, RAM, ROM, and I/O ports. As you can see in the diagram here, we are giving you a chart. In that chart, you can see, just make it out. What is the difference between processor? Because I will just tell you in a very simple word, microcontroller is a chip which has everything inside, whereas the microprocessor, everything is not there inside. Only CPU will be there and other things will be outside the chip. Whereas in controller, everything is inside the chip. That is, it has a RAM, ROM, and I/O ports, everything inside. Let's go to the next slide, please. What are the features you should know about processor and controller? This is a small chart we have made. So what is the purpose? Microprocessor, general purpose. Microcontroller, specific purpose. That is, it will do a certain specific task. Features, again, the component part, when we talk about features components, CPU only. Microprocessor, CPU only. You have only CPU inside. So microcontroller, CPU, memory, I/O ports, everything is there. Cost-wise, microprocessors are expensive. Microcontroller are little cost-effective. That's why we use maximum more projects and we more study about the microcontroller. Power consumption, microprocessor is high and microcontroller is low. Architecture. This is a very important part. All the engineers they should know what are the architecture. So microprocessor use both architecture, that is called as von Neumann and Harvard architecture. Von Neumann and Harvard architecture is used in microprocessor, whereas microcontroller, Harvard maximum time commonly used is Harvard architecture. Correct? So what is von Neumann and what is this architecture? If we study in detail, it will take a lot of time. So I will have just given you some little this thing on the pictures will be there and you can just check it out. Okay. But you have to remember there are two types of architecture, von Neumann and Harvard. Let's go to the, what are the working principle microprocessor? You have to fetch the data, it decodes and it executes. Whereas microcontroller, fetch, decodes, execute with the peripherals for task specific operation. Only one work will be done. Right? Okay. Now, what is the application where it is used? Microprocessors are used for personal computers, high-end servers, general purpose systems. Whereas microcontroller, IoT device, please remember, which is very new, IoT device, home automation, an automotive system. That means your autonomous cars, wherever you use sensors, we use microcontroller maximum. We'll discuss more about this in the coming future. You can see here a few of the pictures I've just taken. The microprocessor Intel Core series, AMD, Ryzen, ARM, Cortex, A series, these are the all microprocessor you can find in the computers or your laptops. Whereas microcontrollers, you will find in a board called embedded system board called Arduino. Atmega 328, Atmega is the 328 is used in Arduino, ESP32, STM32, RP2040 that I will show you exactly after the video. Okay, right. Next, advantages and limitations. Microprocessor, high processing power, but expensive and power hungry. Whereas microcontroller, cost effective, low power consumption, but limited processing capabilities. Only one difference is limiting processing capabilities. Now you will come to the real world use cases. Microprocessor based system, laptop, desktop, microcontroller based systems are smartphone, thermostat, fitness, and so many other things what we use in daily our works, right? So microcontrollers are more in use nowadays, right? So you can see I have just given 4 of the boards here just to show you the talk about the microcontroller, because we will be doing the practicals based on these boards in the coming future. We will be doing some projects, some practical. I will try to explain you Arduino, ESP32, Raspberry Pi Pico, STM32, and different type more boards are there that we will discuss in the coming future. All right, friends and students. So we have come to the lab. I will one by one, I will just show you about the microcontroller. We will be discussing more about microcontrollers, types of microcontrollers, because in the coming future, we'll be doing some project based on these boards only. Right. So you can see I have placed so many boards over here. So I will just explain one by one what are the boards. Let's take the first board. Okay. So first of all, I will just show you where is the microcontroller. Just now we have discussed, we are discussing about Arduino board and we are discussing about the microcontroller. So here you can the center, this is the chip. Okay. This is called the Arduino. This board is called as Arduino. UNO is the name of the board. Arduino is the company. So this is the complete board. We call it as an embedded system board, but remember this, the center one, this chip is your microcontroller. Okay. Now this, what type of chip it is? It is a flat. Okay. Flat type of, we call it as a thin quad flat package. Thin quad flat package. Okay. TQFP package. Okay. This is number is Atmega 328P. You can just find it out. The Atmega 328P. It has approximately, we get 328P on different this thing also, but tip pin also. This is QFP, right? QFP package, and this has 32 pins. 32 pins will be there. Okay, it has it's a square chip. We call it as a square chip, 32 pin with a 32 kilobyte of RAM. Memories will be there. RAM 2048 kilobytes. EEPROM will be there. That is 1024 bytes, and other things will be there. So this is your Arduino board, which we'll be using more for our projects. And you can also maximum. It is very, very popular. Please remember. So that's why I have shown. This is the microcontroller. Okay, let's go to the second one. Second one is ESP32. This is the one. Okay, this is ESP32, right? So what is the only ESP32? It is extends a single dual core 32-bit microprocessor controller. Okay, right? It's a microprocessor. You can say it's a microprocessor also, but it's a microcontroller dual core. Okay. The vendor is SFRIF. SFRIF is the company the vendor who makes. There are 2-3 vendors for this who make this. The only difference is you find a steel, this thing is steel on the upper side. This board, particularly this particular IC ESP32, comes with attachments. What attachment it will be there? Wi-Fi and Bluetooth. That means if you are doing some IoT projects, you will use this type of the ESP32. This is the best for your IoT projects and all. Why? Because it has a 34 GPIO pins, right? 48 pin, that IC will be a 48 pins. And there are so many models. The development model is C8, SH, S series, and H series models will be there. You will have so many, right? Okay. So this is very important chip that is called as ESP32. Okay. Now we'll go to the next one that is called as ESP32, ESP8266. Same tag. It looks similar to this, but the chip is little different. Okay. ESP, we call it as a node MCU. This is the vendor is Tensila. Tensila. It is a low-cost Wi-Fi microcontroller. This also has a Wi-Fi and Bluetooth, but low cost lesser than this. Okay. So this is also a microcontroller board or embedded system board with a microcontroller here. What a 32-bit RISC microcontroller it will be there. Okay. So we call it as a node MCU also. Right. Okay. Same here. This you can see small one. This is also ESP8266. We call it as a 01 model. The first model it has come. It has 8 pins and all, and it has a small chip here. You can see this is also with the Wi-Fi system because you see antenna over here. These are the antennas. like zigzag line. These are the antennas. Wherever you find this, even in this you have antenna. In this also you have antenna, right? Antenna that is on the PCB itself it will be made. So this is 8266. Okay, so two things are 8266, very cheaper in the rate. Or this is ESP1 and this is ESP12 we call it as. Okay, this has USB connection. This doesn't have USB connection. Even ESP32 has USB connection. This has a USB connection, but it is a square type of USB connection. These are a micro USB connection. Anyhow, now we'll come to the next one. This is another chip. This I'm telling you. This is from Raspberry Pi Pico. We call it as RP2040. We'll do some practical based on this. This chip is RP2040. Okay, this chip is also, this is a 32-bit dual ARM Cortex processor. 32-bit dual ARM Cortex processor, not processor, sorry, microcontroller. Okay, so by Raspberry Pi Limited. Okay, this is the company of the name company is Raspberry Pi. Actually, this board has been released in 2021. Okay, even this same board, we have one more board here, but the only difference between these two boards are this has same IC. Okay, this is the microcontroller and this is Wi-Fi chip. Okay, here it is given with the Wi-Fi. Here the same one more board has been released in 2023. That is, we call it as 2350. This chip has been replaced with 2350. It is a bit advanced type of a chip, little bit advanced than this chip. 2350. Okay, that is the chip. So this is by microcontroller. So I'm just showing you the microcontrollers. One more microcontroller I will try to show it to you. This is your STM32. STM32. This is the STM32 board, and here also you have a lot of series. This is made by ST company. The company is different. Please remember. ST company. Okay, so this is very famous company, STM32. You have so many boards in this, so we'll be doing some project based on this. Why I'm showing you all these boards? Why? Because there is a microcontroller in the center. All microcontrollers will have some definite function. All this microcontroller here, in this works from 1.8 volts to 5.5 volts. This will work with 5 volts, right? This is also 1.5 volt or more than that, a little bit more than that. Okay, right? So these are the STM32 board. Now we'll discuss, we forgot, we have discussed more about one more board. That is one more chip we used to study in our colleges and in the institution. This is 8051, the oldest chip. Okay, 8051 or 8052 microcontrollers. Okay, so these are the bigger size, my 40 pins microcontroller, a little bigger in size. If you compare this, it is old, but nowadays we hardly use this because if you want to use this, we should have the complete setup. You can see here, this is the complete setup. You have to program the chip with this programmer, special type of programmer. Then you have through the serial connector, you have to connect it to your computer. And by using a special software that is clean software, you can program this IC. The memory and everything is a bit little low compared to all other disks. So maximum, what do we use? We use this Arduino. We use Raspberry Pi Pico. Of course, we use a variety of projects. We use all these things, microcontrollers. And one more thing I will tell you. This is also ESP32 with CAM. This is ESP32. You have a camera here. ESP32 CAM. It is called as ESP32 CAM. So same family ESP32, but it is having a camera related projects, heat related projects, temperature related project, and IoT related projects. You can do with this. Okay, because this has a Wi-Fi system here. Okay, it has a Wi-Fi system and CAM also camera. The camera is very useful. So camera related projects you can do with this. So I've just shown you the different type of microcontroller. All of them have a microcontroller. We are not discussing about the microprocessor. Microprocessor, it's inside your CPU, but here we are using microcontroller. In the coming future, we will be discussing more about the microcontrollers only.